Hi, welcome to Sunil Maths tutorial. Let us learn repeated limits and some examples. If a function f is defined, if a function f is defined in some neighborhood of the point a comma b, then the limit y tends to b, limit y tends to be f of x comma y if exists. Remember that if exists, limit y tends to be f of x comma y if exists, comma, is a function of x. We are applying limit y tends to be if exists and is a function of x, is a function of x, say pi of x, say pi of x. Now again one more if condition. If limit x tends to a, limit x tends to a, pi of x exists and equal to lambda, and equal to lambda, then we write limit x tends to a, limit y tends to b, f of x comma y is equals to lambda. And also here we say that lambda is a repeated limit. Lambda is a repeated limit of f as y tends to b and x tends to a. This is known as repeated limit. If we change order, if we change order of taking limits, if we change the order of taking limits, we get the other limit. We get the other repeated limit. We get the other repeated limit. That is limit y tends to b, limit x tends to a, f of x comma y is equals to lambda dash. And the most important point is these two limits, lambda and lambda dash, may or may not be equal. May not be equal. Either they equivalent to one another or they not equals to one another. This is the definition of a repeated limit. So to understand this concept, let us see two examples. Example number 1. Let f of x comma y is equals to xy by x square plus y square. Now apply the limit y tends to 0, limit x tends to 0, f of x comma y is equals to limit y tends to 0. If you apply as x tends to 0, you get 0, so that limit is 0. Also further, limit x tends to 0, limit y tends to 0, f of x comma y is equals to again limit x tends to 0, again it is also 0, so you get 0. So thus we conclude that the repeated limits exist, both the repeated limits exist and are equal to one another. and are equal to one another. Now see one more example for the same repeated limits. Let f of x comma y is equals to y minus x divided by y plus x into 1 plus x by 1 plus y. Now let us apply the repeated limits. The first one, limit x tends to 0, limit y tends to 0, f of x comma y is equals to limit x tends to 0, limit y tends to 0. Here the f of x comma y is given that y minus x by y plus x into 1 plus x by 1 plus y. As you apply limit y tends to 0, you simply get limit x tends to 0, limit x tends to 0. As y tends to 0 here, you get minus x by plus x into 1 plus x by 1 plus 0. So you simply get limit x tends to 0 minus of 1 plus x. So as x tends to 0, you get minus 1. This is the order. Limit x tends to 0, limit y tends to 0, f of x comma y is equals to minus 1. Now we are going to calculate the limit by changing the order of the limit. Limit y tends to 0, limit x tends to 0, f of x comma y is equals to limit y tends to 0, limit y tends to 0, limit x tends to 0. The function is given by y minus x by y plus x into 1 plus x by 1 plus y. First, we are going to apply limit x tends to 0. If you apply limit x tends to 0, then simply it is equivalent to limit y tends to 0. As x tends to 0, you get y minus 0 by y plus 0 into 1 plus 0 by 1 plus y. You simply get limit y tends to 0, y by y into 1 by, this is 1 plus y, 1 plus y. Y get cancelled. So again you get limit y tends to 0, 1 by 1 plus y, as you get plus 1. Now you see limit x tends to 0, limit y tends to 0, f of x comma y is equals to plus 1. Limit y tends to 0, limit x tends to 0, f of x comma y, sorry, this is minus 1, this is minus 1, is equals to, as y tends to 0 first we take, then it is equivalent to 1. So you see, both repeated limits exist but not equal. What is the conclusion? Both repeated limits exist. Both repeated limits of f of x comma y exist, but they are unequal. That's it. That is the point. Repeated limits exist, but they are not equal to one another. Right. That's it. Keep learning. In the next video, we will learn 2 more examples or 2 more problems. Depends upon the same repeated limits. Keep learning.